Welcome to Brain Vision.
Okay, so we're finally given a nice softball of a question in this chapter. So we're told we have a 32 centimeter long solenoid, so the length here refers to the total distance from the first coil to the last coil. And we know that we want it to have a 0.3 Tesla magnetic field and a maximum current traveling through it of 4.5 amps. So we want to know how many turns, so how many of these loops do we need for the solenoid for that to work. Well, for solenoids, we know that the magnetic field is just given by mu naught times the current times the number of turns and then divided by the length of the solenoid. So this is just going to be a direct application of this equation. So we want to solve for n, the number of turns. So we can just say that n equals the magnetic field times L over mu naught times I. So we want the magnetic field to be 0.3 Teslas. We're told that the length is 0.32 meters. And then we have mu naught, and we want the current to be 4.5 amps. So we calculate that out, and we get 1.7 times 10 to the fourth. So 17,000 of these little loops here, which is quite a lot, but not impossible over this kind of length if we're dealing with very small, thin wire. So the only other thing worth noting here is that they tell us the diameter of the solenoid, so this width here, but that doesn't matter at all for this problem. So when we're dealing with solenoids, we're pretty much always assuming an idealized solenoid, and so that means then just throughout this whole region here, the magnetic field will just be constant throughout the whole thing. So any diameter that they tell us, the magnetic field will be the same inside.